When in 1684, Giovanni Cassini discovered the fourth moon of Saturn, Dione, he soon realized something peculiar. When he combined, at that time, the number of known planets and moons, 6 plus 8, he got the number 14. And it happened to be that the man who built Cassini's observatory and paid him out of his own pocket was Louis XIV, at that time King of France. He immediately took his findings to the king, showing it as a proof of the divinity of the king's rule. Of course, for his most brilliant achievements, he was rewarded very generously by the king, receiving the role of the head of the Paris Observatory and societal status. But immediately afterwards he dropped all his research. He knew very well that he'd find even more satellites of those planets, and simple arithmetics could risk him losing his established status to the dissatisfaction of the king. Louis is long dead now, and so is Cassini. In fact, they've been dead for 307 years now, Louis outliving Cassini for only 2 years. Time, the great equalizer, brought their societal rift to zero. The king's position couldn't change a single thing about the universal law. Like every other living organism that has ever existed, at least on our planet, their life can be summarized in one sentence. They were born, they lived, and now they are dead. This is what our common perception of time feels like. We measure, we feel, and we live with time in our minds. It has a clear path, past to the future, cause to effect. It appears at least to have a direction, the unchanging past behind us and the uncertain future before us. However, time doesn't seem to be a fundamental quality of our universe. The first problem with our understanding of time is not absolute. It is relative. Picture yourself on a moving train. Now, shoot a light wave from one end of the train to the other. You'll get a value for how long it takes the light to reach the far end of the train. If you're on a platform, however, watching the person on the train shoot the light from one end to the other, you'll get a different answer. To the stationary observer, an object in motion moves through time slower than an object at rest. When the train comes to rest, and on the ground and the on the train observers can meet up again, both of their measurements will be different. Individually, they'll be consistently different with one another. All it takes is a knowledge of special relativity, because time is not absolute. Due to the same effect, time moves faster the farther away you are from the center of the Earth, meaning your head ages slightly quicker than your feet. From this, we could conclude that time is a tentative dimension, but is it really true? Well, let's take a look at the second property of time, direction. Physically speaking, what our logic holds might just be an illusion. Most physics are time independent. What action could take place in our positive time direction could also perfectly work in the negative direction. No laws of physics would be broken. A ball, shot forward, has absolutely the same physical validity as a ball shooting itself back. However, strictly speaking, almost all physics would work this way. There is a principle of thermodynamics which establishes the so-called arrow of time. Here's what I mean. Let's say you drop a cup and it shatters into tens of tiny pieces. Physically speaking, it is also perfectly possible for all those pieces to spontaneously jam back in a way that's just perfect for all the pieces to align themselves accordingly, and to stitch back into their old places. Again, the laws of physics don't really disallow this. They work perfectly well in both time directions. Microscopically, two molecules can form a bond with each other when aligned. But macroscopically, while there is no really rigid law of nature preventing this, it's just unlikely. very, very unlikely. Why? Entropy is the answer. In high schools all over the world, it is taught as the measure of the disorder of a system. More accurately, it's the measure of how many microscopic states a system can be in. Let's take 6 chess pieces and put it first on a 3x3 and then on a 4x4 board. We will obviously see that there are many more configurations in the second case than in the first. In this case, we say that the second chessboard has a higher entropy than the first. In contrast, a low entropy object has fewer states of configurations available. This is where the second law of thermodynamics comes in. According to it, any closed system will tend towards a configuration of higher entropy. And for this very reason, it is impossible for the cup to reassemble itself. It's the same reason why your headphones always seem to tangle themselves in your pocket. They can only be tidy one way and massively tangle in potentially billions of other ways. At large, it's also the same reason why all machinery will break down and we all will, like Cassini and Louis, die. Our psychological arrow of time mimics this thermodynamic arrow precisely. Perhaps because the chemistry in our brains follows this law of physics as well. We experience events in the same direction as entropy increases, from the ordered past to the disordered future. Not all is resolved in rainbows, though. Entropy has one very negative consequence. As disorder gradually increases throughout the universe, and energy gets converted through that increase, eventually, little by little, energy disperses. It becomes spread out until all the energy in the known universe is equal, and subsequently unusable. Our world is also a closed system, which means it also should obey this law of entropy. And it does so perfectly. The most likely scenario is that the universe will continue expanding forever at an exponentially accelerating rate, ultimately turning space into an almost perfect vacuum as the remaining matter energy becomes more and more diluted, a scenario sometimes referred to as the heat death of the universe. Over a timescale of 10 to the power of 14, 100 trillion years or more, the universe would reach a state of maximum entropy and thermal equilibrium at a temperature of very close to the absolute zero, where it simply becomes too cold to sustain life or even motion of any kind, and all that would remain are burned out stars, cold dead planets, and for an eternity, black holes. Eventually, after an almost unimaginable 10 to the power of 100, a Google years, even the black holes will have evaporated away, leaving nothing but random isolated particles floating in emptiness, with little or no prospect of ever interacting with other particles. The implication of this model is that although time was finite in the past, it will potentially be infinite in the future. Although, in a scenario like this, where change is practically impossible, the very concept of time becomes effectively meaningless. The response to the question of whether time exists is, it will not matter.
Said they want to ban candy canes because they're shaped like a J, as in Jesus. Well, listen to me, you stupid twat, and I'm being a gentleman by not using another word to describe you. What if we held it like this? Would that help the situation, you fucking idiot? Have you ever seen a cane? This is what canes look like. So it's a candy cane. Like this. We don't hold it like this unless it's a fucking umbrella, you fucking moron.